Okay, let's see how to make predictions for a new query point. Whenever I say a new query point, I meant to say that this is a point which is not part of your training, validation, or your test data sets. Assume that XQ is a new incoming point into your system. Okay. Now, with the help of the decision tree that you have constructed using your training data, the question is, how do you make predictions for the new incoming points? Okay. Let's try to answer this question in both the classification setting and the regression settings. Okay, let's try to answer this question from the classification point of view. Assume that we are solving a binary classification problem. That is, this XQ will either belongs to a positive or to a negative. I'm referring my predictions with the Y hat. Okay, so Y hat belongs to a set of 0, 1 in the case of binary classification setting. So the predictions that we make for the point XQ will either be 1 or 0. So in order to make predictions for any point in a decision tree, we try to parse the tree from the root node to leaf node. Okay. So, and XQ is nothing but a simple, it's a simple feature vector. Okay. It's a simple feature vector. So now every node will have some condition. So, and XQ will have a feature values, right? So depending on the condition, XQ will be landed in one of the leaf nodes. Okay. Either it will land in this leaf node or in this leaf node. Assume that XQ has been landed in this specific leaf node. Okay. So now, how do you classify XQ? It's just a simple majority rule. In this specific leaf node, just observe the number of positives and number of negatives. There are more number of negatives than number of positives. So we say that XQ is a negative point. Okay. And also sometimes instead of obtaining the class labels, we might be interested in obtaining the probability scores. So computing the probability is very straightforward here. You just need to get like something like this. If you wanted to get the probability of positive point, just get the number of positives by total number of points in this node. So it's 3% positive. Similarly, you can get the negative probability as 97%. So you can say that with 97% of probability, XQ belongs to the negative class. Okay. So this is how we make a prediction for a new query point using the classification tree. Okay. Let's try to understand the same thing from the regression point of view. Okay. In the regression, instead of Y being a class label, so this will belong to a real number instead of belonging to a binary, binary classes. So we know that in classification, we'll be having a multiple classes, whereas in regression, we'll be having a real number. So in classification, every sample will either belong to a positive class or to a negative class. Whereas in the regression, every sample will be associated with a continuous variable, something like this. Okay. I just, put these numbers randomly. Okay. Just for the demonstration purpose. So similar to the classification tree, we also parse the regression tree from top to bottom, that is from root node to leaf node. Okay. Similar to classification tree, when you parse the regression tree, this point XQ will end up in one of the leaf nodes. Let's assume that this XQ has ended up in this specific leaf node. Okay. So now, if it is a classification tree, we'll either go by the majority rule or by the probability. But if it is a regression tree, we need to find some metric, that will aggregate all these real numbers. Okay. So one of the metrics that we use is mean. If you just take mean of all these values, mean of all these real numbers will again give you a real number. So that real number can be a prediction for this query point XQ. Now you might ask, why only mean? Why not median or mode? We have different central tendency measures, right? We have mean, median, and mode. But in most of the cases, we only go with the mean. There is a small reason for this. So for example, let's say you go with median instead of mean. So what happens in that case is that the error rate will usually be higher for median and mode in comparison with the mean. So when I say error rate, I'll just explain what I meant by that. So let's say we compute RMSE scores. Okay, let's say we compute root mean squared errors between y and y hat. Okay, that is the original value and the predicted value. Let's say this y hat is computed using mean. Okay, let's say I'll call this as y hat using mean. Okay, let's say we also compute a root mean squared error for the same point, that is y and y hat. But here, instead of computing the y hat using mean, let's say I compute the y hat using median. So when you do this, you always see that the error rate will be less for mean than for the median. Okay, so because of this reason, we always aggregate the leaf node values using the mean. Okay, thank you.